Your Majesty, esteemed laureate, Your Excellencies, ladies and gentlemen, welcome to the 2025 Abel Prize ceremony here at the University Ceremonial Hall in Oslo. This is the home of the Abel Prize. We are surrounded by some of Edvard Munch's world-renowned paintings. They are telling the stories of the university and of the sciences. Most notably, of course, this blazing sun, celebrating science and enlightenment. Opening this ceremony today was Peter Baden, Astrid Garmo, and on the koto, the national instrument of Japan, we heard Liv Lande. And they were weaving together Norwegian and Japanese traditions in a piece called Fantasia Abel, especially composed for this ceremony by Peter Baden. The Abel Prize was established in 2002 by the Norwegian government, and it is awarded by the Norwegian Academy of Science and Letters on behalf of the Ministry of Education. And today, of course, we are gathered to honor and to celebrate this year's Abel Prize laureate, Masaki Kashiwara. So, ladies and gentlemen, please welcome the President of the Norwegian Academy of Science and Letters, Annelin Eriksen. First of all, Annelin, tell us a bit about the Abel Prize.
The Abel Prize is named after the most famous Norwegian mathematician Niels Henrik Abel and recognizes pioneering and groundbreaking achievements in the field of mathematics.
So why is this prize important?
Science is hard work, and we need to give extra recognition to those who bring us great insights. Being able to understand and explain the mysteries of our existence, of our world, is priceless, of course. But honoring those individuals who make a real difference is important.
So, in your opinion, what makes this prize special?
Many things. It is one of the most prestigious prizes in the field of mathematics, but I would highlight one aspect of the prize that we might not so often reflect on. It connects across time and space. Niels Henrik Abel himself lived in a society nothing like ours. However, despite the more than 200 years that divide today's laureate and Niels Henrik Abel, their ideas unite them. This year's laureate works in a tradition that can be traced back to Abel himself. Our academy, the Norwegian Academy of Science and Letters, is proud to manage the Abel Prize. It is an important part of our work to promote basic research and the field of mathematics.
And this, of course, remains just as important when looking towards the future.
Exactly. And this is why children and youth is such an important part of the Abel Prize.
The Abel Grant also supports young talents and children and youth initiatives. And that's why it's such a privilege to be able to introduce you now to 4 remarkable young talents. They are all parts of Young Talents Baratue, which is one of the leading talent development programs in Norway. And they will honor the laureate today with Allegro from the Holberg Suite by another Norwegian giant, Edvard Grieg. Here is Vigore Quartet. The Abel Prize is awarded based on a recommendation from the Abel Committee. This committee consists of prominent researchers in the field of mathematics from all over the world. Now, ladies and gentlemen, please welcome Chair of the committee, Helge Holden. So, Helge, I've understood that explaining these theories in simple terms is a bit difficult.
I don't think it's difficult. I think it's impossible in simple terms. You have to remember that mathematics has existed for more than 2,000 years, and what was true then is still true. So mathematics has developed tremendously, and it's become very specialized and very technical. But if I am to try, I could start with symmetries.
Okay, symmetries. They're all around us, and humans have always appreciated symmetry, right? So what is Kashiwara's take on that?
First of all, mathematicians, when they study symmetries, they use what we call mathematical groups. And Kashiwara has studied what we call continuous groups. One example is when you take a tennis ball and you rotate it around, it doesn't change at all.
Okay, so I can understand that. But I'm pretty sure, describing how a tennis ball rotates won't earn you the Abel Prize.
I'm afraid not. You have to do more. And Kashiwara has studied this in depth. So the problem is that these mathematical groups tend to be very complicated. So mathematicians have developed a tool that is called representation theory. We take these groups and replace it by something much simpler, matrices and vectors. It may not sound simple, but believe me, it is much simpler to study these objects. And Kashiwara is a world champion in representation theory.
And also, this is the first Abel Prize laureate working outside of the EU and the US, because he has spent his whole career in Japan.
Indeed, he started studying in Kyoto, where he was very much inspired by his advisor, Professor Sato. And he spent his entire career in Kyoto. And he was instrumental in bringing Japanese mathematics to the forefront of international mathematics. And we can hope that the Abel Prize will continue to inspire Japanese, Asian, and worldwide mathematicians.
And in a moment, you will be able to explain the decision of the committee, and His Majesty the King will present Masaki Kashiwara with his prize. But first, let's get to know the laureate a bit better.
I was born 2 years after the end of the Second World War. And I remember my mother, when I was very small. My mother read a book every evening. Yeah. I think when I was in the elementary school, I read 1/3 of the books in the library. I learned that Euclid wrote a book on the geometry, plane geometry. Hilbert found that there is some gap in the axiom of Euclid, and he added some axioms, and I learned it in some encyclopedia. It was fun for me. In fact, I wrote a notebook on the proof by using those axioms. Yeah. I liked mathematics in those days. The most impact is by Mikio Sato. I met him when I was 30 years of the university. So that is, I think, a starting point of my real career or mathematical life. Sato likes very much calculation. He introduced many new ideas, but those new ideas are based on many calculations. He created the so-called Sato Grassmannian. I think most important thing in mathematics is the creation. I think he taught how to create. I think that I learned from him that part. So he was like my mentor. In mathematics, there are many things, and some parts are not well understood. I think there is some hidden part, and I want to find those hidden parts. And I think that is my motivation. Yeah.
Masaki as a mathematician is totally exceptional. He's very special, he's incredible. If you ask a bad question, he doesn't answer. That's clear. But if you ask a good question, which sometimes can appear, and if the question is interesting, then he will solve it.
Yeah, somewhat true.
No, he has a very good intuition. In general, when he says something, it's true, contrarily to me, which says a lot of stupid things.
I think to write something is important for me. I mean, that is somewhat my way of thinking mathematics. So sometimes you use this computer, but I prefer to write. All the notebooks. Yeah, for example, that is when I started the so-called mixed homage modules. Those are rather complicated stuff, and I can't remember anymore. They are completed by Morihiko Saito, but it's not easy to follow now. I have many collaborators, and I still collaborate with, for example, Pierre Chapia or Myung-Ho Kim, Sejin William Park. I think without them, I think it's not easy to continue.
So the macro-local point of view was introduced by Sato in the 70s, and with Kashiwara we did it in the shift theoretical framework, which is, I think, honestly, we did something important. And we wrote a book in the 90s, which is called Sheaves and Manifolds, and which has an enormous success. And I think we have the same feeling, same sense of mathematics, of what is interesting, what is not interesting. But Masaki has a range much wider than mine, of course.
Pierre has some good intuition. I'm quicker than him.
That's clear, no doubt.
I think that is a good combination. Yeah.
Sometimes I have some feeling, but I'm totally unable to prove it. So I ask Masaki, and it's finished in 5 minutes.
But we wrote already 2 books, and we are now preparing the 3rd book.
And we are still friends. Yeah, incredible, no?
As collaborators, of course, but not only for that. We are good friends. Yeah. I'm now 78 years old and more than 50 years in mathematics, and I'm very happy that this is well appreciated by this Abel Prize.
Your Majesty, Abel Laureate, ladies and gentlemen, symmetries are ubiquitous. We find them in nature, we admire them in art and architecture, and scientists have studied symmetries systematically in everything from crystals to elementary particles, the smallest building blocks of nature. In particular, mathematicians study symmetries by introducing what we call mathematical groups. Here I must issue a slight warning. I'm afraid that there is a certain truth to the statement, often attributed to the German poet Johann Wolfgang von Goethe, that mathematicians are like Frenchmen. Whatever you say to them, they translate into their own language, and forthwith it is something entirely different. So here we go. Group theory was introduced by the French mathematician Évariste Galois, developing further the symmetries that our own Niels Henrik Abel discovered in his work on the insolubility of the quintic equation. Group theory has turned out to be a universal tool in mathematics. Another great Norwegian mathematician, Sophus Lie, showed us how to use symmetries to study differential equations. In the second half of the 19th century, he created what is now called Lie group theory, and it is, for instance, hard to imagine modern physics without Lie groups. And this year's Abel laureate, Masaki Kashiwara, has made substantial use of Lie groups in his research. Mathematical groups are, however, notoriously hard to study, and mathematicians have thus developed representation theory, in which groups are represented by simpler and more well-studied objects like matrices or vectors. Often the problems become easier and reveal new properties in this representation. Masaki Kashiwara has used representation theory and made further amazing developments of this field throughout an exceptional career spanning more than half a century. Indeed, he continues to be very active, publishing in some of the premier journals just last year. Here follows just a few examples of his many startling accomplishments. Kashiwara started his illustrious career at the tender age of 23, when he handed in his master thesis, handwritten in Japanese, in which he generalized the famous Cauchy-Kovalevskaya theorem and introduced one of the tools that he would use throughout his career, namely the theory of analytic D-modules. The results were quickly adopted by the international community, even though the thesis itself would only be translated into English 25 years later. Kashiwara's results belong to an area of algebraic analysis. Let me try to explain this further. Linear differential equations are most often studied using analytic tools. However, in algebraic analysis, as initiated by Mikio Sato, Kashiwara's advisor, one analyzes these equations using algebraic methods, which for instance can be used to reveal symmetries of the equation and its solution. Sato started a systematic study of linear differential equations using algebraic means, and it is in this tradition that Kashiwara's thesis was written. At the International Congress of Mathematicians in Paris in 1900, the German mathematician David Hilbert proposed 23 unsolved problems, which subsequently guided the development of mathematics throughout the 20th century. Some were solved immediately, others remain unsolved to this day, while others still have provided the seed for novel theory and generalizations of the original problem by Hilbert. Hilbert's 21st problem, often called the Riemann-Hilbert correspondence, asked for the existence of a linear differential equation on the Riemann sphere with regular singularities and with prescribed local monodromies. Several mathematicians, including the 2013 Abel laureate Pierre Deligne, have worked on this problem. Kashiwara formulated and proved a vastly generalized Riemann-Hilbert correspondence, and indeed recently he and Agnolo extended this result even further. The Kastan-Lustig conjecture in representation theory was also proved by Kashiwara, together with Brylinski, in a striking application of the Riemann-Hilbert correspondence, while an independent proof was obtained by Beilinson and Bernstein using different methods. Kashiwara and Tanizaki later generalized the Kastan-Lustig conjecture to infinite-dimensional affine Lie algebras by developing D-module theory further. Since then, D-module theory has become an indispensable tool and brought numerous new developments in representation theory. Kashiwara is an exceptionally prolific mathematician with more than 50 collaborators. Having spent his entire career in Japan, he has been at the forefront of making Japanese mathematics an international powerhouse. For over 50 years, he has reshaped and deeply enriched the fields of representation theory in its numerous incarnations and algebraic analysis. Kashiwara has shown how to combine results from several different areas of algebra, analysis, and geometry, revealing new and deep connections. His work continues to be at the vanguard of contemporary mathematics and to inspire generations of researchers. It gives us great pleasure to award the 2025 Abel Prize to Masaki Kashiwara. Now I'd like to ask His Majesty the King to come on stage and present the 2025 Abel Prize to Masaki Kashiwara.
Your Majesty, members of the Norwegian Academy of Science and Letters, distinguished guests, ladies and gentlemen, I am very honored to receive the 2025 Abel Prize. This award is a great recognition of my entire research spanning over more than 50 years. I am involved in research in the field of algebraic analysis and representation theory. One of my main research fields, algebraic analysis, was initiated by Professor Mikio Sato. When I met Sato, I was 21 years old, and he just started to construct the notion of micro-local analysis. The idea of micro-local analysis is that in order to analyze the singularity of functions, we do it not on the space, but on the space together with the direction at each point. I was very impressed by his new idea, and I joined the project of developing micro-local analysis together with my senior, Takahiro Kawai. During this collaboration, I learned many things from Sato. Among them, he taught me how important it is to create new things in mathematics. This becomes a valuable guide in my research career. I have been blessed with more than 50 collaborators. They have enriched my mathematical research. Of course, Sato and Kawai were my first collaborators. Later, I solved the so-called the Riemann-Hilbert problem on the correspondence of regular holonomic D modules and the monodromies. However, it was the earlier work on regular holonomic modules done by the collaboration with Kawai that played a key role to solve this problem. Another example is a collaboration with Professor Kiyosato Okamoto. Okamoto wanted to solve the so-called Helgason conjecture in the representation theory of real reductive groups. He asked me to collaborate with him in order to solve this problem. In those days, I knew very little about representation theory. During the collaboration, he taught me a lot about representation theory. Later on, representation theory became one of my main research themes, thanks to his lessons. My encounter with Pierre Chapira also brought a major impact on my research. Originally, micro-local analysis is for the study of the singularities of functions. Thanks to Shapira, I realized that this micro-local method can be applied in many other cases. I would like to take this opportunity to express my gratitude to all of my collaborators. The environment in which I was able to devote myself to research at RIMS and Kyoto University Institute for Advanced Study has also greatly contributed to my receiving this Abel Prize. I am deeply grateful to Kyoto University for continuing to provide such a research environment. To end, I would like to express my deep gratitude to the Norwegian Academy of Science and Letters, and also to Norway, who reminds the world of the importance and the beauty of mathematics. Last but not least, I would like to thank my wife Hiroko for her continuous support and understanding throughout my research life. I believe they have allowed me to devote myself to mathematics and eventually brought the Abel Prize. Thank you.
We have gotten to know the laureate a bit better through this ceremony, haven't we?
Yes, and what a remarkable person he is. Masaki Kashiwara has not only shaped modern mathematics, but he has also inspired generations of researchers around the world. Through his deep insight, humility, and unwavering dedication to discovery.
It's been very interesting to catch a glimpse of that motivation that has kept his work going through more than 5 decades. And I know you're very excited to congratulate him.
Indeed.
So the stage is yours.
Thank you. I would like to extend my warmest congratulations to Masaki Kashiwara, Abel Laureate 2025. Your scientific contributions to the field of mathematics are of great value to us all. We appreciate your presence today and are grateful for being able to celebrate together with you. I would like to take this opportunity to thank everyone who has contributed to the continued success of the Abel Prize. The International Mathematical Union, the European Mathematical Society, the Heidelberg Laureate Forum, the Abel Committee, the Abel Board, and the mathematical community. You have contributed to establishing a highly recognized international prize in mathematics. Thank you.